Here are the test results from the Wurth isolation transformers. In part one, I had identified what I thought was either a mechanical or chemical issue where the leads were failing on these Wurth isolation transformers. And so just a very quick summary of that is that I had 7 transformers fail on the latest batch of boards that I made. And that was a very high failure rate. It was around, I believe, 2%, just over 2% of the parts failed. I've never had this part fail. I've been shipping this product for 3 years. I've been using this part for longer than I've been shipping that product, and I've never seen this failure. So to see it 7 times was problematic. And in the previous video, I had identified what I thought was a mechanical vibration issue that was, I believed, was caused by the ultrasonic cleaner that I was using. Let's see, where's the failure on this one? I picked the one where I never found the failure. Okay, this one's failure is there, so it's going to be pin 3 on the top left. And so yeah, just a quick recap. The wires are breaking at the solder junction, and that is what it looks like. If I can get it in focus there. So here this wire is broken. It should be attached there. You can see how these are attached, but this one is not. I've actually moved it away. It was touching in part 1, if you remember. And so I thought that the issue was that there was no potting. All the wires that are broken, there's no potting on them. So I was like, okay, this is a mechanical issue. So let's try and reproduce the failure. And so before I did that, I took all of the parts off of the reel that I had left. So this is every single part I had left on the new reel. Again, these parts have changed mechanically. They have a different physical enclosure that the new design, I believe, is inferior still. That's still a conclusion that I have. But it doesn't seem to have caused the effect. So how do I have these bend? So what I did is I took all of the parts off, and then the ones that were fully potted, this is my own definition, go in this bin, and the ones that did not meet the full potting requirement went in there. So what is the requirement? The requirement is that 50%, so if we take a good one and put it under the scope here, 50% of the last 50% of the wire before it contacts must be enamel coated. So here you can see that this easily meets that definition. I don't know why this is refreshing so slow right now. You can see we have enamel coating here. This is 100% coverage, 100% of the way. Let's see, so that's a good one. Here's a bad one, and let's see why it's bad. I just randomly picked it. So here we have a wire that has no enamel coating. The whole way down there is no enamel coating here. This looks a lot better in my ocular than it does on the screen here. Probably should have done the autofocus thing again. Whatever. So yeah, this has none. There's actually none over here either. But some of them will have it like halfway. And so my criteria, here's another one that doesn't have any coating there. But my criteria was that the last 50%, so let me get this in frame. The last 50% of the wire, so from here up to where the connection is, must have 50% enamel coating. That was my criteria. And these are the ones that failed to meet the criteria on the new design. So 92% of these did not meet that criteria. 8% did. So that's a pretty low number. Here I had, this is the remaining old parts that I had from an old reel that I didn't use up. And on this case, 80% of the parts had what, the full potting, again, the 50% of the 50%. And just for, we looked at this before in a lot more detail, but you can see here, wow, look at the potting here is so good. And again, the bend, the mechanical bend that this old design has puts so much less stress on here, because any enamel that touches here is going to, any motion that happens down here is not going to transfer across this corner here. On the new one, we have a sharp corner. Here we had a chamfer there. I feel like that chamfer was there for a reason, and yet they got rid of it. But you can see, again, just really, really great. Again, I know it's looking terrible on there. So that was a good one. Here we'll see the bad one. And I will say that the pour potting on these is much better than the pour potting on those. These fail a lot more, and they'll have multiple wires. On this one, when they fail, it's just like, you know, it's 40% coverage and not 50. Yeah, so here this one failed because this the neutral center tap, can't find my razor, there it is. The neutral center tap here is not epoxied 50% of the top. But again, the angle is still providing mechanical strain relief there that we don't get on the new one. So yeah, this is one of the failing ones, and that seems to be the only part where that enamel is missing. So this was a pour potted one, yep. We should have 7 in there, yep. And so what I did then is I took a bunch of the ones that were here that were failing. I took some of the worst of them that had the loosest wires, the least amount of enamel on them, and I mounted them to 2 test boards. So I have test board A and test board D. The reason there's not A and B and it's A to D is that this is test A, B, C, D, E, F. And I abused the heck out of these things. So typically, if you remember, my theory was that this damage was by my ultrasonic cleaner that was basically causing, oh, sorry, it's way too bright. I'm gonna turn the light off for this section. So my theory was that the ultrasonic cleaner was damaging these, either the vibration or the chemical. And so the first thing I did is I took 10 of these, or it ended up only being 9, but I thought it was 10. And I literally just put them in the Branson EC, the chemical that I used in the ultrasonic cleaner, which is designed to clean circuit boards. I left these in that at temperature, 60 degrees Celsius, overnight for, it was like 12 hours. I don't have that on this page. I left these in here for 12 hours and then looked at all, visually inspected them, and did a continuity test and made sure that they still worked, and they all still worked at the end. So it wasn't just the Branson EC. So yeah, the initial test here, no ultrasound or ultrasonic. I literally was just leaving these at temperature in this solution. They did not fail. So then I took different ones. I didn't even retest any of those. I took brand new ones that had failed my visual inspection and put them on these PCBs, and I did a bunch of testing on them. So typically I do a combined ultrasonic plus the Branson. I don't just do Branson or just the ultrasonic. I literally mix them together, and just for 10 minutes, every circuit board I ship goes in my machine for 10 minutes where it gets ultrasound and the Branson EC at the same time at temperature 60 degrees Celsius. So in my test here, first of all, brand new, the check marks mean, do we still have continuity? Has the part failed? And you can see that none of the parts ever failed. And so the first test here, yep, none of them failed. Here I have the cumulative time that the part was exposed to the ultrasonic, the cumulative amount of time that it was exposed to the Branson EC chemical, and then the cumulative time that it was exposed to both. And so this is a CDF function here. It's not graphed, obviously, but you can see at the end of the day, I have 220 minutes that all 6 of these parts were exposed to in the ultrasound machine for, you know, almost 4 hours of ultrasound and almost 3 hours of ultrasound and Branson and 930 minutes of just chemical. So that's, you know, what, more than 15 hours? I don't even know. It's a long time. And these parts never failed, which is crazy because we're spending 93 times longer in Branson. We're spending 16 times longer in the Ultrasound Plus and 22 times longer. And these were the worst parts on here. These are the ones that looked the worst, that I thought would succumb to mechanical failure from the vibration. They never failed. They kept going forever. So that's pretty crazy to me. And it means that my previous theory that I would come in and put some kind of acrylic or polyurethane coating inside of these and replace them all on the boards, the ultrasonic isn't causing this damage, or at least I was unable to reproduce it with a pretty extreme test here, right? Like this test is way more than my machine would give, you know, in 10 minutes versus 930 minutes. or 160 minutes or 220 minutes, depending on how you want to look at it, no failures. And each one of these is not one chance for failure. There's 12 wires inside of each one of these parts that could fail. And again, I picked the parts that were in the worst shape. They had the least amount of conformal coating on the inside. So I was really expecting that they were going to fail, and they didn't. So when your assumptions fail, you have to rethink what is the conclusion, because my conclusion was that I was going to come in here, apply a conformal coating that was going to solve my problem. Whether it was chemical or vibration, the conformal coating was going to prevent that from happening because the wire would no longer be exposed. It would be mechanically secured by the acrylic coating here. But again, the part didn't fail. So what does this mean for the product here? I think that long term it means that the next chance I get, once I've shipped these boards out, which I'm going to ship these boards out, right? Like, and I'll explain that in detail. I'm not just throwing caution to the wind and saying, these are going to fail. I have shipped hundreds of these boards out already, and knowing that the old design had a 20% poor potting rate, where again the enamel was 50% of the last 50% wasn't covered. 20% of the parts I shipped previously presumably had the same issue I identified. I wish I had a larger sample size. Where's my other? Yeah, here's full. I wish I had a larger sample size, but of course I've shipped all of these out. I only have 35 of these in my possession. 34. Can I math? 34 of these in my possession at this point. But if you extrapolate that out to the thousands level, and it stays at 20%, this sample size is large enough that I would think that you would buy a bunch of reels and they would all be 92%. This one is less mathematically valid, but it's still representative. If we take this failure rate, it means that I have hundreds of the old design that have this potential solution as well. And again, I've never seen the failure. And I have actually more on this new batch of just 64 circuit boards, or 70, whatever the number is, 64, 70. On the new batch, I actually have more suspect parts than all of the boards I've sent in every batch previously combined. This new batch has more potentially suspect parts, presumably, again, assuming this ratio maintains itself, which I don't have any reason to believe it wouldn't. And yet I haven't seen the failure on the old ones. And so, yes, I think that if there is a mechanical vibration issue, this latest batch is more likely to have the failures that occur. And the question is did I catch infant failures here, infant mortality, boards that fail immediately? Or am I more on a linear curve? Or is this gonna go up exponential? Is it a bathtub? I don't know the failure curve, but I do know on these quantity 6 that I subjected them to a huge amount of abuse. The concern is, you put these in a car and they vibrate, and then they vibrate because you're hitting speed bumps or just gravel in the road, or you off-road your car or whatever. And so I don't want those failures to occur. But the ultrasound is a ton of energy going into these tiny components. I mean, that's how it works. Like, the fundamental nature of how it works is the cavitation that occurs because of all this energy you're putting in there. It makes things vibrate. And I could not reproduce this failure. And I spent a whole day gathering this data, because every 10 minutes I had to go in and take the boards out, clean them off, and make sure the continuity was still there, that no failures had occurred. And I did the boards one at a time. I did them exactly how I test the board. I didn't put both of these in the cleaner at the same time. I put them in the same way, on the same rails, at the same temperature, and so, it was a lot of work to gather this data. And ultimately, I don't believe my hypothesis was correct. I don't believe that mechanical vibration caused these failures to occur, or at least not the mechanical vibration from my ultrasonic cleaning process, because I wasn't able to reproduce that. And so the question is, what are these? These original failures that caused this whole thing to happen, this whole debug rabbit hole to happen, why are these failing? And I don't know. I am going to hopefully get in touch with Wurth. I've had a really hard time getting in touch with their team. their email address for support bounces. When you send an email, it just immediately bounces and says the inbox is not accepting emails or whatever. So that's not great. I have called and left a message, but I need to call again and just see if I can get a hold of someone and kind of see what's up. As far as when this part change occurred from the mechanical enclosure, I believe that it happened in April of 2024, which was less than a year ago, last year basically. It's February of 2025 as of this recording. So it's a pretty recent change. And, so obviously I still want to figure out what the failure mode is. I don't believe it's from my ultrasonic cleaning process, but these were brand new parts. And the only thing that's happened to them is they've gone through the reflow oven and they've gone through an ultrasound. And again, I use leaded solder, so my temperature is way lower in my reflow oven. And my reflow oven is quite well calibrated. Even though it's a DIY cobbled together thing, it works very, very well. That was not always the case, but it's fully characterized. The profile is spot on. It's well within this part's requirements, and I have many more parts that have more sensitive temperature requirements than this one that haven't failed. I mean, this is just copper enamel and some solder on posts or whatever, versus things with temperature voltage references. Typically, if I burn a board, it's really obvious on the 10K potentiometers. But I don't do that anymore. Some of my early boards had that issue, but not anymore. My process is very well done, and I don't see how it could have caused copper to melt, because copper's melting temperature, if you're unaware, is much higher than 10 lead solder melting temperature. So definitely didn't melt the copper here. You would have not had, the whole plastic structure would have been gone. The enamel would be burned on these wires. The polyurethane enamel would be burned and gone. So I don't understand the failure, and so I think it's time to kick the can here. Give these over to Wurth if they want them, which I would hope they would, because it seems like I found 7 in just a reel of parts or whatever, partial reel. I think I had 200, about 250. I bought a partial reel for these. Anyway, what does this mean for the boards I already have? So the boards I already have, I have tested them extensively. Of course, I have these failures. I've actually tested them all again after my conformal coating step, which I don't normally perform that step, because applying conformal coating, you shouldn't discover issues after that. But I have tested them all again. I did find one additional one that failed after that. And so, they're tested again. They're working now. I have high confidence that they're going to continue working. But I also would say that, given again that the number, just the sheer quantity on this latest batch is higher than the suspect quantity on all previous boards I've shipped, it won't surprise me if 1 or 2 of these in the field out of 65, 70, whatever the number is, have a failure at some point that is deemed to be this. And so the question is, okay, well, do I scrap all of these boards? Or my previous thing was I was going to replace all of the parts on them, but again, I don't see a reason to do that because I haven't identified the root cause. I don't believe it's vibration, so conformal coating probably ain't going to fix that. The real concern I have is maybe some of these parts are broken when I get them, because I haven't done any conformal coating. I've only done the ultrasonic cleaning. I don't know. Maybe the machine that wraps the wire around before I get solder was tearing the copper, and that would be a Wurth thing. That it's a part-specific manufacturing thing. So I am going to ship these units as is, with obviously working. The ones that are broken, I'm replacing. But I don't see a reason to put a conformal coating on here on this batch, because it would take me days to do that on this existing batch. I don't want to scrap this existing batch because it's tens of thousands of dollars in parts, and so it does mean that there might be a very slightly higher RMA rate on these boards. We'll see. We're in beta. You can't build to perfection. Building to perfection is very, very expensive, and so I am going to ship these boards out If there is a failure, I'm going to fix them at cost, or for free actually, sorry, at my cost, at my expense. So if you send a board back that has failed and I determine it is because of this isolation transformer issue, I'm not even going to charge you anything. I'll cover your shipping, right? I don't think that will happen to more than 1 or 2 people based on what I know now. I, of course, I log all the serial number range that I build. If Wurth comes back and says, you know, actually, yeah, there is an issue. The copper we used in this batch was defective and it is going to fail, you know, then I'll issue a recall. But until that happens, you know, engineering pragmatism requires optimization. And so in this case, the optimization is that I'm willing to accept a slightly higher risk of an RMA rate, you know, from effectively 0% to 1% or whatever, 2% to 3%, whatever the number is. My RMA rate is not high. Most of the RMAs I get back are not product failure, they're use failure. They've been used incorrectly. Wires have been connected wrong. The car has flooded, etc. So, you know, and I don't see any reason to hide this. There's full transparency here. There is a slightly higher risk. The long-term solution is that I'm going to rev the board. I'm going to design this part out. I've lost faith in this part. So unless Wurth comes back and says, hey, look, the issue is this. Here's how we're fixing it. That's what I would expect. If they don't come back there, in that case, I would continue using the part. But if they don't come back with anything that's helpful, I'm going to just design in a new, better part that I qualify, where, you know, I'll buy 100 of them, you know, turn them over, make sure they look good, the conformal coating's good. And then I'll, of course, have to rev the board. I've kind of wanted to do that already because this is a dual part. And so this transformer, for example, goes here and there. This one goes here and there, and then this one is coming from the source and goes here. And so you end up having a lot of stubs, and this is a isolation current transformer, and so those stubs actually cause a lot of reflections. And some of y'all will remember that the Rev B boards that never shipped had a lot of noise issues that my alpha, I say they never shipped, I shipped 5 of them to alpha customers. One of those alpha customers immediately identified this issue, and then fixing it was a huge chore. But it is working now, and so there is risk that if I go in and yank this transformer out, put a new one in where the stubs are closer, it should make these stubs much shorter and there shouldn't be as many reflections. And so there's minimal risk that it will cause problems, but of course it has historically been a problematic circuit. At this point, I don't believe those errors are happening. If a single error ever occurs, your LIBCM unit will actually log it and it will display an E on your screen. You know, you have the FGH, I forget what the last B, FGHB, the little flags or whatever. There's actually an E that will come up. If you ever see the E, that means you've had an error. And when the key is on, you know, we're measuring lots of data on here, so you have hundreds of opportunities per second, probably thousands, probably tens of thousands of opportunities per second for bit errors to occur. Because this is all ECC. We actually have a checksum in here. We know if a data transmission failure has occurred because our checksum won't match. And so we can log that. And so again, you have 10,000 opportunities for failure per second. And I've never seen the E since I've implemented my fix. But there is risk, changing this out, ripping this circuit out, putting in a new transformer is going to cause that failure, where we have the noise issues again. It's a low risk, but the point is to say, I have never really been terribly fond of this part, but I've never had a reason to get rid of it. Because of course there's a lot of cost in having to rev the board, engineering cost, my time basically to build the new board. But at this point now we have a part that I don't really like anyway, that has a failure mode that I've never seen, that I can't quite quantify why it's happening. And so yeah, I'm gonna get rid of it. But I have 125 of the existing circuit board. I'm not gonna scrap those. I've already, I've built 70 of them. I've built about half of them. So I'm not going to scrap all those. It's very expensive to do that. If I send these out and suddenly they're all failing in the field, at least we'll know what the problem is. It's pretty easy to detect this failure because the failure is you can't talk to one of the 5 systems that's measuring the voltages on here. In my engineering experience, and you know, whatever, I've decided that I think that the risk of shipping these units is very low. If the failure does occur, the system will catch it immediately. You will hear annoying beeping. The screen will display issues, you know, that, you know, things not working. And so the burden, the cost is that if this fails in the car, you're gonna have to take the pack out. And, you know, for the 1 or 2 of these that happens, it is a burden on my customer where it takes them a couple of hours. You know, and of course they have to send me the PCB, and I've mostly sent advanced replacement PCBs whenever failures occur, so there's very little downtime. Of course, in this case, the downtime, you can't drive the car as soon as this failure would occur until you get the new circuit board. But this is a beta program, and if this even happens, I think it's going to happen to 1 or 2 customers. The inconvenience will be a couple of hours of work having to pull the pack out, put the new pack in, versus me spending days replacing all these parts. But then again, I don't even know what the issue is. So even if I were to put a conformal coating on these, pull all the old parts off, and these are now conformally potted, put them onto the new boards, there's no guarantee that it's actually fixed the issue because I don't know what the issue is. And so the solution long term, I'm going to go to a Rev-E PCB. But for now, we're going to ship these. I've already weeded out 7 failures. That's not that one. Whoops. I've already weeded out these 7 failures here. I only have 6, so there must be 1. Yep. So here are 7 customers who were not inconvenienced because of my testing. Hopefully there's only 1 or 2 customers ever that in any amount of time have this failure, if that ever even occurs. I'm not sure it will. I don't know if this issue existed when they came off the reel, so I don't know. I would hope that the manufacturers testing each one of these, I would be amazed if they weren't, because testing the 12 pins with a continuity or an induction tester would take fractions of a second on a good test fixture. Anyway, it's probably enough here. I am very confident in this product still. I hate that this issue has crept up. I'm glad I detected it before I shipped these out, and that comes down to having a really good tester. You can see part of it hiding back there. I do 100% test the boards before I ship them out. Every connector, everything you interface with, every cell, every voltage, and a lot more, you know, stuff just on the board with voltage references. I 100% test that before I ship it out. So I'm very confident in the product. I wish there was a very happy ending of, oh yeah, mechanical vibration has caused this. Okay, we're going to take them off, repair them. I don't know that is the case, so I don't see the reason to do the work. And I would hope this community would bear with me if there is an issue down the road, which I don't even know is going to be the case. Yeah, thanks for watching.